Morning. No coffee today. Hot water. Hot water. How's everyone doing? I'm a few minutes early. Whatever. A few people in the chat already. Awesome. The H is here. G'day Michael. Hi Andy. Hey Jonathan. Azzy's here. And Kane Thornword. Tiny LED Matrix is here. Hello. G'day Peter. Greg is here. Mike Swan. Des. Maxine R&D. Wow. Hello Colin. Are you new, Colin? I think Colin is new. No, you were here last week. Wow. Community is getting quite large. So, I have 2 screens now on my desk. 2 screens. Two screens. So I'm going to be looking around like this a lot. My camera's over here, and my chat is all the way over here. No lemon juice and honey. So, I'm just warning everyone now. Hello, Mike. How you doing, mate? I am sick as a dog. I don't know, that's a term here in Australia. I don't know if everyone has that, sick as a dog. Anyway, I am super sick. And I'm on antibiotics, and I'm stuffed with cold and flu tablets and nasal spray, and I'm not drinking coffee. I'm drinking just hot water, plain hot water this morning. Lots of buffering. Is anyone else saying buffering? Internet looks good. There's no drop frames, so I wonder if the internet's bad. I had trouble getting to YouTube this morning. Greg. We'll talk about that, Greg. We'll talk about that. Anyway, so I'm warning everyone now, just getting it right out of the way. I could spontaneously combust. I could just break out with a coughing fit or a sneezing fit, and I'm going to try to hit the mute button as quick as I can, but it might not happen. I'm just warning everyone now. I shouldn't be streaming today, but I'm just too excited. So I'm going to stream. Okay, I'm sorry if anyone's seeing buffering. It could just be the internet. Wow, lots of messages just went past. So, sounds laser printer acting up. My laser cutter. I shot myself in my sinus. I've got a sinus infection. I get them often. So yes, exciting. Thank you, Peter. Peter S, thank you. Yes, very exciting to get the board working first time. There's the 2 of them. So, just something very funny. And I know I complain about my messy desk all the time and everyone laughs at me. So I've just been finding random passives all over my desk here. So I had to pull my desk out yesterday to get my 2 screens up, and I had to literally pull everything out of the wall and get behind, and when I was cleaning everything up, I was just finding random passives everywhere. So they're probably all good. They're used when I swap things out. No, it's not getting me down, my illness. Well, a little bit. I'm not sleeping very well, but I'm just, anyway, obviously I'm excited. So I'm just going to move those out of the way. I just thought I'd share my little passives everywhere. I found some more as well. I don't know where they are. I found some 0402s, but they're gone. They're long gone. Yeah, seriously, if I start sneezing, I've got my tissues next to me. I've got a whole bunch of these. What are they? Werther's original. Oops, you can't even see them. They're like little sucking, no sugar sucking lollies, just in case my throat starts going. So, yeah, you've all been warned. So, before I start with the rev2 stuff, I just want to just have a one-on-one with Greg. Did you call things? No, it's not a one-on-one. It's for everyone. So the charging situation and the flashing charge LED. So, hello Rob, how you doing? How was your night out, Rob? Fab, you say hi to Alex too. I don't know what that was about. Oh, hi Alex. Hi Alex. So, you would have seen, or some of you, whoever saw my Rev1, it's live video, would have seen me comment about the flashing charge. Now, let me just pull this out, pull the power out. So the flashing charge LED that happens when the power is plugged in and there's no battery plugged in. See this here? Now, Greg commented on my... G'day Daniel, how you doing? Hello Looney. Oh, it's Looney's trash today. G'day Brian. Hey Jonathan. Hang on, one thing at a time, Jonathan, hang on. So, Greg commented that this was not expected behaviour and that his experience was that there was a problem with the LDO. I took a look at Greg's video and what he was seeing on his was totally different to what I'm seeing on mine. On yours, Greg, yours was on all the time and it was flashing bright and dull. These aren't. I've tried 3 different charge ICs now. I've got my, everything's too small. So this little cap here, that's a 10 microfarad cap, that's on the VBAT. So there's no, this has got the stability circuit on it. I am ill, I'm very ill, but I'm too excited. So I'm streaming. Happy daughter now. Cool, glad to hear, Rob. So this here, this is just a known, like every board that I've got here does this. And it's on all of Adafruit's release notes and, you know, whether it should be flashing or not is really open for discussion because I've got 2 WeMOS boards and they both flash. Lowland 32s, I've got 3 feathers, they flash. I've tried 3 different charge ICs on here and they all flash when it's like this, when there's no battery plugged in. So I don't think this is the same thing that you're experiencing, Greg. And I'm pretty confident this is fine. Like, you know, it'd be better if it wasn't flashing. So I was running this on and off, 2 different lipos. So let's just plug this one back in. It's just been running off battery for a little bit. So the issue, so if it's a charge issue, if this flashing light, so you can see it's charging now. So if that flashing light was the issue Greg was talking about, then the chances are that it's not going to detect when the battery is full and it could continue overcharging the battery. That's the issue, right? That's the concern with not having stability on the charge. I mean, not, yeah, the charger, did I say, if I said LDO, I apologise, I meant the charger. So, I meant the charge IC. Interchangeable. I'm drugged up. There you go. So the issue would be that it wouldn't stop charging. Now, I charged and discharged, or not discharged, I charged and pulled it out and charged and pulled it out stacks of times yesterday. Hello Chris, you haven't missed anything yet. And it definitely cuts off. Sometimes it cuts off at 418, sometimes it, 4.18 volts, sometimes it cuts out at 4.17. It definitely cuts out. I've also put 3 different, so some of those resistors that were lying around before, I've put different charge rate resistors on here just to check as well, and they all definitely cut out. So long as the charge detects that the battery cuts out, is fully charged and can turn off, that's all that matters. If it's not turning off, then you've got a problem. Now, a few people have commented that the reason there's a flashing is that the chip itself, or these chips, can't detect the difference between no battery and empty battery. So when you plug a battery in and it's empty, or it and it needs to charge, it can't tell the difference between the battery not being there or not, and that's why that flash is. And that flash is it looking to say, do I need something to charge? Do I need something to charge? That's what the theory is on what that is. Of course, it's undocumented. If I just leave this here, well, who's buffering now? Okay, well, Greg reckons that's a red herring. I don't know, not from what I've read. I've read that any time, well, that's the thing to be concerned about, right? Does the charge IC charge the LiPo, and does it overcharge it? I'm sorry if it's buffering again for anyone. Anyway, you'll see that'll charge, that'll go off shortly. Right, no battery or bad battery. Yeah, well, hopefully not bad battery. So, I'm just going to leave that. You'll see that charge light go off soon. I've got a pretty high resistor on here, so it's a very slow charge. And of course, the last lot of charge on the batteries is super slow. But you'll see that turn off soon. Anyway, so, hang on, drink. For those that missed it, I'm not drinking coffee today, I'm drinking hot water. When I'm sick, I don't like drinking milk or dairy. I try not to. It adds to the... Yeah. So, rev2. Yay! Good, I'm glad there's no buffering. Yeah, I couldn't even get onto YouTube this morning. So I had to restart my computer and restart my browser to get to YouTube. So maybe there's something funky going on. So does anyone, before I jump into revision 2, does anyone have any questions or anything about revision 1 or anything? Thanks, Chris. I'll get better when I'm ready. I jumped on the antibiotics straight away this time. I don't like taking antibiotics, but I jumped on them. I got them yesterday. I started taking them yesterday. So after apply, I also googled the room lost low on 32 reviews and saw no flashing LEDs when USB powered. And saw no flash. Okay, I've got two WeMOS Lowland 32s and they both flash. So I don't even know what ICs they're using either on those ones. They're the labels are completely like the screen printing them's gone. It's so tiny. Yes, it is tiny. Apparently it's not small enough. So I keep looking at the chat and my camera's over here. Maybe I should move my camera. Everyone, you want me to move my camera? So when I'm looking at the chat, I'm looking at you. I don't mind. This is all new, this setup for me. You're not alone. I'm on honey and lemon, hot water too. Oh, no way, tonsillitis. That's even worse. Hope you get better soon, Gavin. It's, I get sick whenever there's a change of season. Have my whole life, unfortunately. Take a look at the whole course in antibiotics. Make sure you take the whole... I will. Dear soldering 0402. No, you don't do 0402 with an iron. You can. I wouldn't. Anyway. John, yes, did John, you made a comment earlier, John. I think I missed it. I'm just going to scroll up. Sorry about the chat. I'm scrolling up. Did you ask a question before, I think? John asked a question, I missed it. Jonathan asked a question about the MCP 1700. I've not looked at it, but how low is the quiescent current on it? No, it's not small enough. Who wants it smaller? Everyone wants it smaller. Hey Looney, do you want it smaller? Hey Tiny LED Matrix, do you want it smaller? I know Matt wants it smaller. Okay, I'm going to switch over to Eagle. Hello Wolfgang, can you give the charging IC when the LiPo isn't connected? Can you give the charging IC? How do I give the charge IC exactly 4.2 volts? I've got 5 volts in. I'd need to put a dedicated regulator on there that was adjusted exactly to 4.2. It's not worth it. I'm happy with, you see the charge light's off. I'm happy with this. Whether it's an issue or not, it's a known thing and it's been stated everywhere, all over Adafruit's website that it's harmless, and even on SparkFun's website. And I'm not saying that Adafruit are the be all and end all, but I'm quite confident with them turning around and saying it's harmless. More smaller. I don't need a smaller. I just commented it was just slightly bigger. Yeah, Michael Best. Hey, Michael. Commented that it was a bit bigger than the Room 32. Yeah, but it doesn't have to be the same as a Room 32, I think. I'm not going to... So, one of the ideas originally was to make a castellated board, but I'm not going to make it. Can you get it smaller? High resistor values. But then, what? I don't know what... See, Tiny LED Matrix wants it smaller. I heard a rumour you wanted it smaller from Looney. Flash underneath. No, I'm not putting anything underneath. The problem with smaller is sacrifice broken out I/O. Well, no. So that's the interesting thing. 10K is quite. What are we talking about? 1.6 micro amps on that MCP 1700. Okay, I'll take a look at it. How much is it? That's the other problem, right? I don't want to stick a $3 LDO on there because it's, as it is, the bill of materials is high. So, you know, and what are we talking about now? I want exactly the same size or smaller. This is smaller than the D1 Mini. Let me get my Mini. Whoa. That's the Mini. It actually fits inside the Mini. So maybe a shield for this that connects to the Mini. What LDO am I using? I'm using an AP2112K. The AM. What are we talking about? What are we talking about, Brian? I don't know what we're talking about. I'm using the AP2112. Just because I've got hundreds of them and I'm comfortable with it. Hey, Dave Darko. So that's why I'm using it on there. But they're standard footprint. Like they're SOT 23, -5. I mean, I could swap it out with a different lipo. I've got other lipos here. Lipo. I've got other LDOs here. Sorry, my head is seriously muddled. I've got other LDOs here that have got higher quiescent current, but they've got other characteristics like this can only take up to 6 volts input, where I've got other ones that can take up to 12 volts, which I was going to put on here because I don't really care so much about low power on this. And for instance, then I could allow 12 volts to come in from the DC jack. So I was thinking of doing that on this. But so how could I get this board smaller? Well, it's interesting. It's not about shorter in length, it's about narrower. So if I got it narrower, I could still keep the same I/O, the same amount of I/O, but I'd have to get it, this is the challenge, right? I'd have to get it exactly 2.54 millimeters narrower to get the headers in the right spot for a breadboard. So that's quite a big amount. It's this much between 2 pins. Shorter, narrower. So I just wanted a deadboard that gives you 2 free holes on each side on a normal breadboard, didn't you? Or more. Yeah, I did. Where's the breadboard? I don't even know. What does that work out to? Yeah, so that gives 2 on each side, but I could get 2 and 3 maybe. I know Matt wants it smaller. Micrel, enable line, reverse polarity protection. This has got an enable line as well. I just don't really use it. I don't see what the value is on disabling the... at what stage would you ever disable the LDO? Because... Oh, Peter. Hold your horses. At what point would you disable the LDO? The only time you could ever disable the LDO is when you're guaranteed that the battery that's plugged in is as close to 3.3 volts as possible. So the Pico, I've been trying to do some research on the Pico. If I plug 4 volts into the Pico, we've got a problem. If I plug a fully charged battery in there and the LiPo's turned off, and the LDO's turned off, too many acronyms, and the LDO's turned off, we're in big trouble. So allowing the user to turn off the LDO is, yeah, I don't know. Smaller, but more I/O. Yeah, okay, sure, Looney. Remote on off. Matt is crazy. Who's Matt? Wait, who's Matt? Those vibes look big. Okay, so, okay. Does everyone know I've moved on from version 1, right? Okay, let's talk about version 2. Now let's talk about what I did with version 1 first. So version 1, I had some prerequisites for version 1, okay? So this was my smallest board. I can't get closer, can I? No. This is the smallest board. Wait, maybe I can get closer. if I bring it up. Let's see if I can get closer without reflection. It's reflecting. I need something. Hang on. Maybe this will work. See if I can focus on this. Hang on. Focus. Yes. Okay. Go buy a different board, Looney. ESP-PICO is programmable using the Arduino software, yes. You just need to choose the PICO development board, not a standard ESP32, because they're different. So, my version 1 board, my requirements were this, right? It was the first time making a board this small. It was my first time using 0402. Obviously, I've used 0603 before, but not this many. So it was a combination of 0402 and 0603. And it was my first time where I was using only QFN parts for 2 ICs. So I made the decision that I was going to build the board to the same specs I normally build, which is normal size wires and minimum of 8 mil for track width. Okay? So the reason that the board is the size it is, and you can see the traces, and you can see how big the wires are, that was a conscious choice. I didn't want to introduce into the problem smaller traces and tiny wires if I had to debug these boards and try to work out why they weren't working. Turns out they work, right? And turns out I didn't have to rework them and they were fine. So, great. But I didn't want to take the chance. Like, you know what I mean? When you're going from A to Z, sometimes it's not safe going A to Z. Sometimes you want to go A to P, and then you want to go P to Z. So that was my decision on this. I didn't want any new influences on my version 1 to hamper me getting this board working. Does that make sense? I hope it makes sense. So, everyone's saying, oh, your wires are too big and your traces are too big and you can go 4 layers and blah, blah, blah. Right? I didn't want to do that on my first board. Question, the other day you received a huge wrong paste stencil. Can you show what was wrong? Well, what was wrong was the stencil was too big. So I've confirmed, I spoke to JLC PCB. I'm moving my camera. I feel like I'm talking to the side. There you go. Now, except the light's in the way. Hang on. Now I'm talking to my chat, kind of, sort of. Sort of. No, that's not 12 mil. There's 8 mil. Power is 16 and 12, and all I/O is 8 on this board. So now this stands in the way of the light. So I spoke to JLC PCB about it. This is not the first time I've spoken to them about it, because I've had the problem before. And they agree that there's a problem with the validation on the website. What happens is if you choose the stencil and you say, I want a custom stencil size, and you put the size in, you also have to hit the radio button. And just by typing in the data, it doesn't select the radio button. So if you type in, this is the size I want, and click OK, the radio button's still on the other one, and so you get a full-size stencil. And sometimes when you click on the radio button back and forwards, it doesn't stick. They're aware of this. They agree that there's a problem. They're going to do me a deal on my next order to compensate, because obviously my shipping cost went up dramatically by an extra like 10 or 12 US dollars because of the size of the stencil. But since then, Alan K, who's not on at the moment, he showed me this. Whoa, I just kicked my light. Sorry. I'll show you something. I'll show you something cool. Didn't miss in the background. Sarcasm. Oh boy. I'm just going to zoom out for a second. I just want to show. So I can cut the stencil down. This is my revision 1 ESP32 board. So this is a stencil, doesn't get used. This is the first one they sent me that was the wrong size. Okay, but what I'm going to do, I'll just show you here. If I get to the edge, pair of sharp scissors. They've got to be sharp. You can just cut a stencil. There's no warping. There's no bending. So I'm just going to cut mine down. Yep, strong scissors. They don't have to be strong, they're just going to be sharp. They can be normal household scissors. Don't use tin snips. Tin snips bends the stencil. You want super sharp scissors. Anyway, that works really well. So I'm going to... Well, I don't need to cut this one down because I'm not making any more of these revision 1. But if it ever happens again, I can cut it down. So that's really cool. So thank you, Alan, for that, although he's not here right now. That's what I was going to try with another guy. Yeah, sharp scissors. Make sure they're very sharp. And don't use things like this. Don't use little handle scissors like this. They've got to be really sturdy. They can't be bendy, right? Just letting you know, because what will happen is you might cut it, but the pressure bends the stencil, and once you've bent it, you'll never get it straight again. Right, you can use a guillotine. You know what you can also use is, you know, the paper guillotines, the ones that you know, that's got the sliding thing. You slide the knife across. They work as well if it's super sharp. Yeah, the paper cutters. Yeah. So they also work. Scissors won't be sharp once you're done. That's okay. You know what? $6 for a new pair of scissors. And stencils, a bit more expensive. Okay, so I'm going to switch screens now. And I'm going to show you that. Now I've got 2 boards to show you. There's a lot of stuff to go through. And there's going to be questions, I know. Just let me get through stuff, please. Because I've got different boards in different stages. And what I actually thought I was going to do was, I might actually on the stream today improve my boards. As in go through some of the changes I'm going to make. Not from the redesign, because the redesign's done, but in terms of the sizing and spacing. So let's start with some Eagle. Okay, this is my revision 2 board. What I'm going to do is go through the changes I've made on revision 2 first, before anything else. Okay? I'm just going to bring my... do we want to see... I don't know how I'm going to show you as a comparison to revision 1. That's okay. You have to play Ta-Da Wave when showing revision 2. I'm on a Mac. I don't have Ta-Da Wave. Oh well. Ta-da! Ding! Okay, so this has been a complete redesign. I'm trying to get it as big as I can so everyone can see it. Can everyone see it? I'm just going to turn some layers off to make it a bit easier to be able to see. Actually, what I'm going to do is also turn off my bottom layer for the moment, just so it's easier to see. So I've done a rearrange of the ICs. I've packed it all in. I've rearranged everything. All the headers, look at all that space for the label. So all the headers have been moved to the left. Oh, see, now my camera's on the wrong spot. So where my board before, I don't know, how do I get, maybe I'll, yeah. No, I'm not gonna get my other board up at the same time. Yes, it is very clean, thank you. So I wanted to move the headers further away from the antenna. Full screen mode. Full screen mode is not going to give me that much more space. Sorry. Full screen mode is going to make it go behind the chat. Thank you, Looney. So, yeah, I've moved the headers further over, and where the button was at the top section up here before, just up here was the button. It's now been moved inside. I'm still trying to source a smaller button. I found a couple of smaller buttons, but I haven't found a footprint for them. Hotkey things for streaming to play random sounds. Yeah, I still want to make one of those HID touch things that Brian was working on his stream. I just haven't got around to it. So I've packed everything in a lot tighter. I've moved quite a lot of the components to 402 that were 0603. I've even moved the LEDs to 0402, although the only reliable footprint that I've found are these ones, which are pretty big. That's 0402. but for some reason they're just really massive pads. And I'm thinking of swapping those out just for standard like resistor pads before I go production. Now, these are still using my normal size, well they're not, they're using smaller wires, but the annular is still big, and I'll go into that in a moment. All my traces are now 6, or all my I/O traces are 6 mil, and all my spacing is 6 mil. Now, JLC PCB on a 2-layer board can go down to 5 and 5. I'm not prepared to go down to 5 and 5. Yeah, John, that's one of the reasons I don't want to go to a smaller button right now, is although I found some smaller buttons online, they're the same manufacturer at the moment as the ones I used to use, and the actuator length and stuff were terrible. They were really hard, terrible to push. The buttons I've got now, I love them. They're really cheap, they're from China. They have got a really nice mechanic on them, but I could save, you know, a mil and a half if I went for a smaller button. But anyway, I can live with this for the moment. One thing I want to note, like a few people have commented to me when they looked at the first revision, is a lot of people have been saying to me that I've got my placement of my ICs wrong. That the CP2104 should be sitting down here, and the chip should be up here, so that way the RX and TX lines are close together, and I don't have to do all this wavy stuff, right? But it doesn't work. Right? The problem is all these chip manufacturers need to start talking to each other. So when you look at the 2104, the problem is the RX and TX are sitting in between the RTS and the DTR. And the RTS and the DTR need to go in a completely different direction to what the RX and the TX has to. Right? So the only way I could get these oriented differently, or positioned differently, where I could get rid of these curvy lines, the board would have to be wider. Or what would happen is I'd lock myself out of my I/O on this top section here, or at the bottom. And the bottom is super important, because the bottom is where where the antenna comes out. Yeah, I'm not using micro wires. None of my wires are micro wires at the moment, so I don't know where that comment came up. Tabletronics, just letting you know. So what I've done is my wire size now is 11.8, which is pretty much the smallest that JLC PCB will do on a 2-layer board. Important things are RF cleanness and clean power. Yeah, I know wavy doesn't matter, but people were looking at this and going, whoa, you know, why don't you just move the chips and get them closer? Well, that doesn't really work, right? What I do is I get closer on some things and I get worse on other things, right? There's always a trade-off between, you know, trying to get 2 sets of pins close often means that other things get further apart. So this is the best balance I can come up with. Let me tell you, I have got about 11 revisions of this board where I've rearranged everything all over the time. So my wires, so JLC PCB have 2 sets of specifications. The capabilities on the 2-layer board and 4-layer board are very different. They can go much smaller, wires and annular is the same. Wires and traces are much smaller on a 4-layer board. I like wavy. I think it looks sexy. So this is as small as their drill can go on a 2-layer board. But one thing that I've never really played around with, only because I've always been a believer that don't go the smallest you can go. Like I generally use 8mm traces on all my boards. I could go down to 5. JLC PCB can go down to 5mm. But the idea is you should be using this as thick as you possibly can. And you should be using, like, the width between should be as big as you can get away with. There's no point going small just because the manufacturer can do it. Because you potentially introduce shorts between them, manufacturing issues. They're much harder to debug. So that's why for my version 1 board, I went standard. Standard what I'm used to. I've had dozens of boards built that way. I've never had a problem with the manufacturing process. So that's why I didn't want to do anything. But for version 2, I have 2 versions I'm working on. So, sorry. So this one here has got 6mm traces and 6mm gaps. Smaller, but what I haven't done, and I'm going to do now, is change my annular ring size. Now the annular can actually go down to 3 mil, but I'm not going to do 3. I'm going to actually put them down to 4. Apply. Okay, and now you can see how much smaller my vires look. They're the same size vire, same size drill, but they're a much smaller annular. The annular is the distance here between these two, between the inner and the outer. So there's 3 different settings that you can have with a vire. For those people that already know this, I apologise. For those that don't, you've got your drill size, which has a minimum and maximum specification. You have your overall vire size, width, and then you've got your annular size. So by dropping my annular, all of a sudden I've got stacks more space. I can get all my vires closer together, right? I can pack things in tighter. One mistake I made on my, it wasn't a mistake, one thing I did on my revision 1 board is I got this 0.1 microfarad 0402 cap really close to the IC. Makes it very hard to rework to put flux and run an iron down the side of the strip here when you've got a cap right next to it. So this alone on my 2-layer board gives me a lot more space, all right, and I can pack things in. But I still run the problem that, let me just turn this back on, so standard, but turn off my, whoops. It's turning off both my places just for now. I've still got the problem that I have spaghetti with my signals, right? I'm still needing to route power everywhere on the bottom because I need to get power on 3 sides, well actually 4 sides of the chip, because Espressif decided to stick power everywhere, and with a massive ground plane in the middle, ground pad in the middle, I can't route my power through. So the amount of islands I end up with is terrible, as you can see. Well, for me it's terrible. I mean, there's nothing wrong with this. Nothing wrong at all. But when I do a fill, you can see I've got lots of islands everywhere. I've got ground vires everywhere joining all these islands, right? So if you look at all my islands here and all my islands here, routing ground and power it's done, it works, but it was a nightmare. I thought vires connect to one side of the board or the other. What are those vires with nothing connected to them? That's what, they're connected one side to the other side. So this one here, this ground, that's connecting ground island from the front, the ground fill, to the back. So I've got 2 different ground fills, because I've only got 2 layers. Now this is 4-layer. I'll get to that tiny LED matrix. So because I've only got 2 layers, I'm doing a fill, ground plane fill on the front and the back, and you can see where I've cut them off, just down here. So I'm leaving a lot of space away from the antenna, which isn't really necessary on the back, and again, we'll get to that in a moment. Wow, I'm going to hyperventilate in a moment. I'm not breathing, I'm talking. By the way, my nose is blocked, so I'm breathing and talking through my mouth. G'day, Alan. I need to stop and breathe. Well, turn on orphans for your fill, to fill the islands. To fill the islands? What do you mean? I'm already filling the islands. The problem is the number of islands, John. Now, I mean, this is routable, and I've done it. I've routed it. It was a pain, an absolute pain to route, but it's done. So this is revision 2. Now I've got a stack of space here for the antenna. We'll talk about the matching network in a moment. But it means anytime I make one move, I potentially have a problem. The other thing, and this is an aesthetics thing for me, and it really annoys me, is any place that you have a vire. Now it's different if they're tented. A tented vire means that they're not, the tin isn't exposed, right? So you can't put a they're not solderable. You can't stick a multimeter on them, and there's no continuity between front and back. If they're tented, they've got solder mask on them. So there's no, they're blocked up. Now, the smaller the via, they automatically get tented, which is great. But on my previous board, they weren't, and so what would happen is any place that there's a via, silk wouldn't sit on it, which means like this charge here, it would cut off the bottom of the R. Not a big deal, I know, but for big labels, if I just go to the back, oops, we go bottom, presets. So some of these big labels, like here, the RST, that would chop off the R. Right? This would chop off the bit of the S, that would chop off the S, and I don't like doing that on my labels, right? Because I want them readable. Anyone got easier? Be careful of the islands that seems to pass when it shouldn't. Yeah, you need to double check all of your connectivity. I don't know, that could just be a bug with EDA, right? So it's important for me to get my labels done. So one thing I did do on this board, these back labels are 20% bigger than what they were in my revision 1. And even my front labels, I've got as big as I possibly can. Let me just go back to the front. Top. And if I just go to my... No, I think I've got them on top names. I've literally got these. They're right on the edge of the solder mask, of the tinning. You don't like silver parts that small. Properties and click orphans on the lower left side. Okay, hang on 1 second. So right click on what? So just let me rip it up. So right click on this, properties. And what does orphans do? John, can you explain to me what orphans does? Looks like it's... Is it just sticking extra ones in that it wouldn't normally? That would just be for a more even copper fill, right? Interesting. Let me just rip it up again. So I'm going to turn it off and have another look. It fill without having to have the vias. How would it feel without having to have the vias? I understand the vias are to get front to back. I know it puts copper everywhere, but how does it... The vias are not to go from... Like these two... Oh, hang on, where's the example? That via there and that via there, they are to go to the back to then come back to the front. I don't understand how having the orphans... Did I just turn it off? I'll have to look up what this actually does. Like I'm not getting in here and I'm not getting in here, but I don't need ground in here. Right, I need these two vias. I can't get ground from here to here without going to the backplane. Without going to layer 2. Right, on layer 2, the ground is connected on those. Oh, in this case, I've actually got, sorry, I've got it, I've been rearranging, but when these vias were bigger, it was cut off. When I had the annular bigger. I can leave it off and on, but I'm not sure what it's going to save me. Like, I don't need ground around these things. The only thing it's going to do that I can see here really is give me a more even copper spread. I believe it's called ground plane stitching or something. I mean, if it allows me, if I turn on orphans, yeah, I mean, other than filling non-connected islands, if it stitches the front and back, great. Yes, if you need ground, you just... If you need ground, if you're just trying to fill. is more aesthetics, while having orphans is better for... Right, it's better for controlled impedance because you're getting a consistent ground plane. But yeah, it's not going to allow me to get ground from one place to another place that isn't connected. I still need to go to the back and come back to the front again. Ooh, my picture's gone dark. Let me just... Hey, that's better. Cool. Stream going okay? Cool. Health is good. Great. So, okay, let me just... So, if I just go back to... Turn it off again. Get a bit of isolation. So I've got a lot of room now on my revision 2. Like, I could just send this off. This is working. It's great. I'll get to the antenna in a moment. It's more space. Okay, let's talk about... Wait. Let's talk about the other changes I made. I'm all over the place right now. I'm just going to grab some tissues. Just mute 1 second. Please tell me that was muted. You want the amount of copy being etched away to be equal everywhere on the board. Yep. Thanks, Peter. Okay, so the other changes I made on the board, remember I mentioned IO16 was a wrong one. So IO16's been removed. What I've also done is I had 3 volt and ground up here on these first 2 pins. I personally like having power and ground on both sides of the board on a development board because you never know where you want to be able to access them from. .3 on the front. Yeah, I could do power. I'm not a huge fan of doing a power plane if I don't need to. I mean, sure, it'll get rid of a bunch of ugly routing on the back that I'm doing. But you got to also remember this board's tiny, right? It's not like it's a... oh, you going? See you later, the H. Catch you later. Thanks for joining. Right, it's not like... It's not like this board is so big that the amount of traces and stuff I've got going over are massive, right? Let me just focus. Okay, I mean, if you look at the back of the board here, and you look at the islands, and you look at the routing tray, like, it's tiny, right? It's not really a problem, you know? Like you look at my trace length and go, oh, I can't believe I have to route ground, like, power all the way from here to here. We're talking about 1.5 centimeters. Like, it's tiny, right? So the other changes I made, yeah, so I got rid of power and ground from this top, and I got rid of 16, and what I've done is I've broken out more I/O. So there's now 15 GPIOs broken out on this board. Train ants. I want robotic ants to assemble my boards. Andy, make it so. So 15 I/O is pretty good for this size board, I would think. Sorry, I'm distracted between chat and what I'm talking about. Now, there's no point on this board do anything else to it. I mean, I can use... Hey, Agim, how you doing? Thank you very much. Now that I've got smaller annular and I've got more space, I could pack this in tighter, but there's no point right now. There's only 2 possible things I can do with this board going forward right now in terms of the changes I can make. Well, there's 3. 2 of them are opposing, right? And I've been chatting with Matt Trentini about it, and he wants both, but they're opposing things, right? He wants to add PS RAM to the board, but he wants the board smaller. Now, right now, the only PS RAM that we can add is a SOP 8. It's quite large. It's the size of an AT Tiny 85. It's massive. Let me show you how massive it is. I'm just going to pick a random Sub 8. What have I got? That'll do. I don't know what this is. I think this is a dual transistor. I'm sticking just a dual transistor on the board, okay? For some reason my board is gone wacky size. That is the size of PS RAM if I put it on. I need to fit that on the board somewhere. So assuming that I put it like there, which is a bit too close to the aerial, but assuming I could get this on, I keep calling it aerial, it's an antenna. Same thing, right? Interchangeable, right? To get that in there, I'm going to obviously have to move everything over. But if I put that on, there's no getting the board smaller, right? Now, I could potentially, without this, I could get everything closer together, put the button over here, maybe, and drop this header down 2.5 mil and get the board narrower. I could get it one breadboard pin row narrower, which would make a smaller board, right? But once I've done that, once I've committed to that, there's no way I'm getting PS RAM on the board. It's just not going to happen. Unless we can find a smaller IC. Plenty of space. See you, Jonathan. Thanks for joining. I'll have a look at that MCP 1700. Thanks for letting me know. Using aluminium, a metal antenna. The metal antennas are bigger. So, or the ones I've seen, I can't find a smaller metal antenna than this. What I can do is I can find I found some ceramic antennas that are a third of this size. That's pretty small already, right? I mean, let's be clear. That's a pretty small antenna, comparatively, compared to the size of a PCB antenna. Okay, that's a small antenna. Now, the advantage of using a metal antenna is you can get your components very close to it. So, if I put a metal antenna on there, I can actually save half of the distance. I can't get closer. Half of the distance that I've broken away the chip from the like that open space, I could get it closer. You can potentially get smaller RAM, but I'm talking about... So right now, there's only one bit of RAM that's certified by Espressive, and I don't have the link to it right now. There's one PS RAM that they certify, that they use with the room, and it's the one that everyone's been putting on their Pico boards as well. There's the 3.3 volt one, and it's the only... I don't know what the difference between aluminium aerial and aluminium antenna is. And so the only one that Espressive are officially supporting right now is a sub 8. So Matt's looking into smaller ICs, potentially, but... So right now, PS RAM on the Pico 4 is not supported. People have got it working, yes, but it's officially unsupported, but Espressive, or Angus from Espressive last week, made the statement that now the community have got it working. So the reason it's not supported is they haven't got around to it yet. Just to be clear, it's not that there's anything wrong with it, but they spent a lot of time tweaking PS RAM to work on the Room 32, for instance, and getting the timing and everything right. They just have not got around to certifying and supporting PS RAM on the Pico yet. But now that it's been done by the community, they've committed to actually make it official and to get it supported in the IDF, which means PS RAM will be supported on the Pico, but the one that they're certifying is this particular model that's SOP 8. So, yeah. Now, to the comment about on the bottom, no, I'm not putting it on the bottom. Remember, I'm going to build these boards, folks. I'll never be going to a scale where I'll be doing the manufacturing overseas, and even if I did, as soon as you add parts on the other side, your production cost goes up through the roof. Right? I don't mind putting a Lipo on the back because I can hand solder that, and I did hand solder it, and it's nice and easy to do. I'm not putting surface mount parts on the back of the board. It's not going to happen. Okay? I know it's been done. Look, it's here. It's everywhere. That's great. It's just not something I want to do, right? I need to be able to build these. I need to be able to support them. My aim in life is to not make my life harder. It's to make it easier. So yes, it can go on the bottom, but I'm not going to put it on the bottom. Hey James, that's just a decision I've made. Well, I don't know what it. I would assume it was more than 2 times. It was 2 times. It might be more. I don't know. Plus, I just don't want to have to build it myself. I don't have to worry about reflowing 2 sides. Now, if it's a SOP 8, I could probably hand solder it, but again, it's just not something I want to do. Right? This is I did mention at the start that I'm trying to make a small board. Not the start of this stream, but in general, I want to make a small board. I'm not looking to make the world's smallest board ever. I could potentially, Looney. The other question is, who is PSRAM useful for? Right? Like it's not necessary for every application. It'd be nice to have. Obviously for MicroPython it'd be very important to have because it's an interpreter that takes up a lot more memory. But depending on what you're using it for, you don't necessarily have to have it. It could go on a shield, sure. There's a lot of options, right? But right now my aim is to see where I can get it on the top of the board. I'm looking at making my life easy. And the 2 options for on top of the board are make space for it on top of the board or try to find a smaller IC. And the other thing, just jumping back to the antenna again, is that, so these antennas are about 40 cents each. I can get an antenna that's much smaller, that like literally goes from this cross, you can't see what I'm looking at. Whoops, sorry. I can get an antenna that's this size, like that's from here. But let me see if I can outline it. It's about this big. The antenna's about that big, or even smaller. But they go up to between $1.80 and $3 each. Right, so 4 layers. Right, let's just look at this matching network for now. I just want to quickly go through this as well. Now, just because my antenna worked on my revision 1, that doesn't mean it shouldn't have a matching network. So this is just a standard reference design for a matching network. I'll just show you here. I'm not going to go through the whole... I've been doing lots of reading. Thank you, Peter. I would say with that antenna, smaller have smaller performance. I'm not sure that the smaller ones I'm looking at are actually much taller. They're a 3D. So this ceramic antenna here is still classed as a 2D antenna. It's in a ceramic case, but it's 2D. But the ones I'm looking at, there's a Molex one, which is this big here, and it's a 3D antenna. So apparently it's got better performance, but it's $3.50 per antenna. Sure. I'm not saying rev2 is the finished version of the board, right? This is a journey. I still have to find... we need to find some PSRAM, right? I need to find something that works for us. And if we can find a smaller IC, I'd rather use a smaller IC. And if that's the case, then it can just come standard with it. So, with the matching antenna, this is just using a standard reference antenna. I know I can do all those things, folks. I know, break out the bottom. I've heard, I know I can. Well, actually, right now I can't because there's no room on the bottom. Not with a 2-layer board. There's no way I'm going to be able to route PSRAM to the bottom. I'm just letting you know. Not easily anyway. How much efficiency are you sacrificing for size, cost? Hey Paul, in terms of the antenna, it depends on the antenna I go for. Is that what you mean by efficiency? Or are you talking about production efficiency? This board is going to depend on long range. Most of the I/O stuff is working within a high signal strength area. I don't know what the intended applications for the board are, James, because it's a board for other people to use. I don't know what they're going to use it for. I think if anyone is wanting longer range Wi-Fi, they should be using LoRa. So, Wi-Fi can do 20 meters, 30 meters, but, my WeMOS doesn't do 30 meters very well. Right, you're talking about sorry, was that yes to antenna, Paul, or was that yes to production? Sorry. Oh, hello, Matt. Matt's here, everyone. Say hi to Matt. Matt, I've been copying grief on the PS RAM. Not grief, that's fine. Everyone wants PS RAM, so we need to find a smaller chip if we can. Can't keep my eyes. No worries, Mike. Thanks for joining anyway. I know it's late for many of you, and I appreciate you all being here. Crawl to bed. Walking's better. Let's go back to this antenna. I want to get the antenna out of the way. I've got more stuff to go through. So this is just a standard reference design where it's using caps and using an inductor to try to balance the impedance for impedance matching on the antenna. And the values I've got here are just from standard reference, from Expressive. I don't know what values I need to put here. It's going to be completely hit and miss. I don't know if any of you know about... Hey, Stephen. You know about Smith charts? I took a look at Smith charts and I immediately decided that they're not for me. They're it's way too difficult. So what? Okay, I'm putting my hand up. I'm saying from 0 to 100 in terms of knowledge of antenna design, I'm at 0. Okay, I'm at 0. That's my disclaimer. I'm going to talk about what this does, what this stuff here does, because Bit Looney wants to know. But please feel free to correct me if you want to, or just feel free to let me ramble, because I know 0 about antenna design and network matching. But what this network's designed to do, like some boards have one of the caps, they have 2 of the caps, they have 1 inductor, they have 2 inductors. There's all different combinations of this. And what they're designed to do is, in a really bad... I'm gonna get some pen and paper. I'm gonna draw something really badly. This is completely wrong. Everyone, this is wrong. Because this should be on a Smith chart. But I'm not gonna do that. I'm gonna draw something very wrong, but to kind of give you an understanding of what that's designed to do, apart from matching impedance, is that if you look at something like this, okay, I'm just letting you know this is wrong, that if you look at this being the ideal antenna strength due to all mathematical stuff, right? Adjusting the caps and the inductors and which ones you use and what values you use, right? Then what that does is that adjusts where you sit away from your ideal. Imagine if this was on a sphere. If this was a sphere, which is what your Smith chart is, please, seriously, I'm really dumbing this down, okay? Then, if this is your ideal position of where you want your antenna and gain to be, like this is a gain, like this is your antenna map, right? And you're over here, then what you can do is you can adjust. Sorry if I'm right in the microphone. Sorry if I'm speaking too loud. Yeah, I'm gonna draw something very wrong. Then if you're over here, what you can do is you can adjust which caps you use and inductors, or use them or not even use them at all, to shift yourself back towards your ideal position. That's what they're used for, right? Now, if you look at... I don't have one. So, I was looking at the TT Go, the Micro 32 chip, and the Micro 32, so it kind of looks like a module where you've got an antenna here, and you've got the PICO here. They've actually got, on their antenna, they've only got 1 cap. That's it. Their whole matching network is their trace width and 1 cap. Because that's all they needed in their design to get them, well, I don't know where they sit on their Smith chart, but to get them as close as possible to where they want to be for their best antenna design. I don't know what a polar graph is. It's called a Smith chart. You guys can look it up if you want to. I'm not going to look it up now and show you on here. It's a 3D sphere antenna gain noise distortion chart. Something like that. It's absolutely full on. So if you really want to know, the link that Peter S... Hey Peter, are you a mod? Just ping me. Ping for a second. Say hi. If you're not a mod, I'll make you a mod. I'm going to get Peter to put a link to the document that he sent in my comments on my revision 1 video. Not my revision 1, my very first one, hey, here's my design. Let me tell you a story. Read the document if you really want to know. It goes into Smith charts and stuff. It's absolutely wizards stuff. I know nothing about it, but what that antenna network does is allows you, if you actually... Good explanation, well done. Really? Wow. Holy moly. I'm making Peter a moderator. You're a mod, Peter. Can you, if you don't mind, can you post that link to the document? So that's what the antenna matching network does. My problem is I don't have any of the testing equipment, spectrum analyzers and all sorts of stuff, to even be able to test my implementation to know where it goes. So putting values there and what layout I do and what values I do is like doing what I've done here is exactly the same as me not doing it at all. Because I don't know what this is going to do, right? This could give me worse reception than what my Pico has got right now, my revision 1. I don't know, but this is the standard reference design. Thank you very much, Peter, I appreciate it. But what this reference design allows him to do is, at least from the inductor and this 1.25 picofarad cap, is I can just pull them off. Like if I find that my antenna signal is not great, I can take them off or I can swap them for something else. Obviously I can take C5 off and I can just bridge it if I need to. But the idea is that with this layout, I can swap parts out if I need to. I can put bigger caps, I can put smaller inductors, bigger inductors, and I can tune my network if I need to off this reference design. The problem is I've got nothing to test it with. I'm not running out and buying a spectrum analyzer, and I know I could borrow one or I could go to somewhere that's got one, but I don't know how to use one. I don't know anything about them. So I'd be fooling myself into thinking that I can do anything useful with this antenna matching network. But I'm going to put it on there anyway. Okay, and I can always rip it off. My worst case is I take it off and I have the same level of Wi-Fi that I've got on my Pico 1 right now. My TinyPICO 1. Wow, I need a drink and I need to breathe. Whew. What you're supposed to do with these is you're supposed to leave, or on a prototype board, you're supposed to have exposed pads, and then what you can do is you can tap into those pads with a spectrum analyzer to be able to read values. But I haven't exposed the pads because I can't do that, so I'm not going to do that. Tim just suggests we just copy one of the modern designs, including the balanced circuit with 3D metal antenna. Yeah, the 3D metal antennas are bigger, Matt. I really don't know if I want to go there right now. These values here are Espressive's reference for their board that they use. I don't know. Thank you very much, Peter. So that document's 36 pages. It is pretty full on. If you want to put yourself to sleep, go read that. Yeah, Chris, that's what I'm saying I can do. The only thing I can do to validate this is to swap values and check it against strength, Wi-Fi strength. But that's pretty hit and miss as well, right? That's total gamble. There's so many factors that come into play with Wi-Fi strength, you know. So what I've actually done for my revision 2, I've got a shopping cart in LCSC already. I've actually got in my cart 3 different inductor versions, 5 different capacitor versions. So I'm going to have enough stuff that I can play around with them. Yes, a big learning curve, and I don't even understand it, right? I don't even understand it. I understand it enough to know that I should put it there, but I don't know. The other thing is you need to get as close to the antenna as possible. And with a 2-layer board, it's not overly important to have a ground plane underneath it, but with a 4-layer board, you ideally want to bring your ground plane underneath the antenna as well, just for impedance matching. But yeah, I haven't done that yet. So The metal antennas are bigger, but you can play components almost right up against them. I know, they're also taller as well. I know, Matt. We haven't found me a footprint yet. If anyone's found a footprint for a metal antenna that I don't have to pay for. So the BOM cost right now is sitting around $10. And if you consider you can buy a Wemos board, or you can buy a TT Go or anything else with a Pico for like $7, $7 or $8, then my BOM cost alone is already more expensive than you can buy a board for delivered. The ceramics are working. Like, as I said, I've got, it's still a 2D antenna, as I said, and my Pico D1, my TinyPICO, right now has better reception than my SP32 board does. When connecting to my Wi-Fi, just in my office here, which is a direct line, well, my Wi-Fi is just over there, it's not far, 5 meters. My Pico has got a by 10, whatever the value is, that gives you when you scan, and it gives you like a negative whatever. $10 at low quantity. At 10 boards. Well, obviously I've got 120 PCBs, but at low quantity. But the price breaks don't go great. Like, I need to be buying thousands or 1,000 Pico D4s to get them low enough to make much of a difference. So end up paying around $10 for an ESP32 module because they raised the shipping. Right, but that's still delivered, right? These are costing me $10 for my BOM cost. That doesn't include my build time and my testing time and any profit in the process, right? That Cypress paper is actually excellent. Peter, it really helped me, gave me a real kickstart, and also taught me that I don't want to play with Smith charts at all. So, what's RSSI? I don't know what that is. I'm sorry if I missed any chat going up. I apologise. If there was a question and I missed it, please ask the question again. So that's my rev2, but I have something else to show. So before I finish on this, with smaller vias, smaller annular, I can definitely pack this in more. I have more space. I might be able to squeeze the board smaller, but I'm not going to yet. Received signal strength indication. Okay. Oh, is that what that value is next to the when it shows you the Wi-Fi? So, explain to me. I'm pretty sure I know. I'm pretty sure Alan explained to me, Alan K already. So the closer to 0, the better, right? So it shows you in negative numbers. So if I've got a value of negative 70 and a value of negative 89, negative 70 is better than negative 89, right? Yeah. But so the lower the number, lower meaning closer to 0. I think you asked that already, James, didn't you? I missed that one. I can, but I don't want to, because I don't want people to have to use an external antenna. Could I add an antenna connector, like a ULF connector as well? Sure. Parts costs go up. They're not cheap, unfortunately, UFL connectors. So I could give people the option of using an external one, but it must have an onboard antenna. Now, I could use a PCB antenna. Obviously, it takes a lot more room, and they're not quite as good as the ceramic antenna, even though they're still 2D. And that'll save me 30-something cents, but I don't think it's worth it. The chart is a log. Yes, more positive is better. Okay, well, so my Pico, I keep switching between screens. My Pico D1, my TinyPICO, God, I'm having a bad day today, gets negative 70 to my Wi-Fi, that's a repeater, and this board gets -89. And my D1 Mini gets -87. So, TinyPICO, room 32, ESP8266. That is what I'm getting right now. Make the matching antenna a challenge for YouTube. Make the matching of the antenna a challenge. Thank you. Seriously, I've got so many drugs in my system right now. I'm feeling spaced out. Yeah, I know it's logarithmic, station 240. Hello, station 240. I don't think I said hi to you when you came on before. Yeah, I understand it's logarithmic, but I was still assuming, like, whatever. So if being logarithmic, these are pretty close, right? But I'm pretty happy with this. Like, that's you know, I was... So my expectation always was that this antenna was going to work, that this design was going to work, but it was going to be terrible, right? That was my expectation, right? It's very hard for it not to work. Like, I'm considering how close I am. I don't know what that'll do in terms of distance, but right now my TinyPICO seems to be ahead of the game for no reason other than fluke, right? And I'm kind of concerned that putting a matching network on is going to affect that. It might end up being worse, and if it's worse, well, then I can pull the matching network off, but I'm going to have a nice big blob of solder to bridge everything, and that's going to affect the impedance as well. Happy on drugs. There goes the family channel out there. Okay, legal drugs, legal. Okay, just so we're clear. Okay, I'm going back. I'm off on a tangent, as always. So, yes, I can improve the revision 2, but I'm probably not going to. I'm not going to pack it in tighter yet, because I don't have any PS RAM to put on there yet. And I'd like to build a revision 2. I'm happy to go to revision 3. I'd like to build a revision 2 just to see how it's working. But I did this yesterday, much against my better judgment. Looks exactly the same, doesn't it? If you don't want to worry. Yeah, I can put 0 ohm resistors on them, for sure. But there's still resistors and solder, right? So, it might not be a lot, but it will affect the impedance a bit. Route the traces though, remove the tracks from the experimental version. Yeah, maybe. Well, I don't want it to be experimental. Like, I'd like it to be... another board, sound keeps giving and giving. So this is also revision 2. But, ready for this? 4 layers. I built my first 4-layer board. Wasn't that fun? Can anyone notice I don't have any ground, or got very few ground wires everywhere? Let me just do a fill. It looks funky. This is what a 4-layer board fill looks like in Eagle. Ah! How's that for colour? Are you all blind? So, I did a very quick lesson in... Let's get rid of that. Very quick lesson in 4-layer board construction in Eagle. I have no idea if this works. This is DRC compliant. I don't know what CAM files I need to use to export this. Performance better than comparable larger footprint boards is good enough for my purpose. Are you looking to squeeze more performance out of the next revision? What do you mean by performance? Performance in terms of Wi-Fi? James? Ta-da! So, here's 4-layer board. Now, on a 4-layer board, I can make my traces smaller, but I didn't. Because again, there's not a lot of room to be saved by going from a 6mm to, I think I can go down to 3.5mm. I'm not going down to 3.5mm. I'm just not going to do it. It's just not worth the risk. But, let me just get rid of some of this. There we go. But check this out. If I go to my back I've got virtually nothing on here. I don't have any. Let me isolate it. Oops, wrong one. I don't have any power anywhere. Move the power planes from around the antenna. There is no power plane on the antenna. So what I've got is this. Let me just go back. So this yellow plane is ground. So my layers are signal or whatever, ground, do it over here, ground, 3.3, signal. So my power finishes here, that's the orange one, and my yellow one is ground. Eat more fish. What am I eating fish for? You should make more board when you're on legal drugs. Thanks. Oh, what are you suggesting, James Peterson? Well, yeah, I'd like to, James. I'd like to improve. I'd like to make the Wi-Fi strength as best it can be. Right, I mean, that would be the gain. The problem is I don't have the expertise or the tools to do that in a what's the word? In an educated way. Educated, not word. In a, like, you know what I mean? Like it's going to be guesswork. I'm not just going to stick a whole lot of components on there and go, yep, this is what it is now. Like I'm going to play around with components and see what I can do. But my ability to quantify and improve the antenna mathematically just doesn't exist. Right? That's the problem. Folks, my throat is killing me. I'm going to have a little bit of a sucking lolly. Oh, hello, Tim. No, don't move the ground plane away from the antenna. No. You want ground plane under the antenna with a 4-layer board for impedance matching. It's in every bit of documentation I've read. Well, this will be an interesting discussion, Tim. It's awfully bad where? There is a ground plane around the antenna, Chris. This yellow one is under the antenna. Everything I've read says that on a 4-layer board, you want ground plane under the antenna. As in it... What? As Peter, you don't want to have any copper plane around the antenna. None. Well, I'd have to bring the document up. That's not what it says in your document, Peter. It says you want to use it for impedance matching. Okay, interesting. Well, that's easy to fix. All I need to do is go like this, right? But, okay, I'll have to read the Rain Sun documentation again. I don't remember reading that on the data for that. Well, easily fixed. Look. Oh, now there's nothing there. Hey! Grabs the lozenge. Perfect solve. Okay. I'll have to go back and find the link that I read. Okay, maybe it's antenna specific then, if that's the case. Which means I'm going to have to stick another ground wire on. One moment. So, let's go 8 for ground. And hang on, I'm just going to rip that up so you can see what I'm doing. And what about right there? Cool. Whoa. And I need to get rid of that one. Come on, Eagle. I know that looks ugly. I don't like ugly. There we go. Done. See you, Brian. Thanks for joining. You need the ground plane under the antenna trace, not under the antenna itself. Oh, Maybe that's what I read. Thanks, Brian. Bye, Alan. Okay, maybe it was under the trace I was reading and not under the antenna. That's quite possible. Remember, I was doing all this... yeah, I'm not allowed to say the D word anymore, am I? I was doing all this under medication. So, I've now got a 4-layer board. Now, 4-layer was interesting. My first thought was a question of capacitance. I would also rotate the inductor clockwise by 90 because the thin trace under the cap is an inductor too. Also, this scale wires are inductors. So you're saying... so you're doing something like this, Peter, and then just attaching ground. Hello, Death Shaker. We'll do some more reading. Yeah, I'll do some more reading again. There's a lot of conflicting information on the internet about antenna stuff, let me tell you. Okay. Well, I'll fix all that up in a moment. So I don't know how many people here have done 4-layer. So I did it once and then I had to redo it all again. And I'll tell you why. So here's my layer setup in Eagle. I'll make a note to come back and revisit the ground plane under the antenna when you're better able to concentrate. I'm able to concentrate, what? There's no distractions. Try rotating that 180. Why would I rotate at 180? Okay, I mean I can do that. I was just trying to keep everything, the problem with 180 is ground's in the way now. I was trying to keep the antenna trace on the matching network packed in as small as possible. Wow, what's going on with my positioning? Weird. Sorry, I don't normally use Eagle on here, so this is, can't remember what size trace I used. Yeah, that's a bit funky. I don't know why I do it that way. Yay, Bitlooney's now at 0. Wonder for conflicting opinion. What about regulated transient response in the evaluation? Hey Marcos, I have no idea what you're talking about. Regulated transient response. Anyway, back to the 4-layer stuff. So my first increment, my first idea, so this is just using, I'll explain what this is set up. This is currently using 4 layers where I've got pre-preg between signal and ground, I've got core between ground and VCC, and I've got a pre-preg between VCC and the bottom signal. Now move the inductor down and to the left a hair to reconnect ground to the ground trace. Oh, I see what you're saying. Yeah, but aren't I... Yeah, I guess at this scale... With this scale, I guess it doesn't really make a difference if I'm making that longer. Oh, don't like that. I try to only have 90-degree angles, minimum. I don't like doing smaller angles. See you, Matt. Thanks for joining. Have a good day at work. I'll chat with you during the day. Yeah, I can move it lower. Oh, gosh. I normally use Eagle on my other computer. This is the first time I've actually sat using Eagle here. I'll fix these traces up later. Okay, I want to get... I need to talk about this 4-layer stuff. So as I said, this is using pre-preg top and bottom rather than core. That's what JLC PCB use. And of course you can see it's quite large, the core's quite large to isolate stuff. Now my first inclination was to use buried vias. And so a buried via allows me to go between different layers without going all the way through the board. And there's something really cool about buried vias that I started implementing. So I designed the whole 4-layer board with buried vias. The problem with buried vias are they make the production much more expensive. It's a much more intricate process to do with buried vias because you're not just drilling straight through the board. You're drilling different heights, and you're potentially drilling. Well, my buried vias were only going top to ground, top to VCC, and bottom to ground. There should be ground on the measure network. Oh, the Mac is weird. Ooh, Matt. Okay, I'll speak to you about that. No problem. You should never have 90-degree angles in layout. Yeah, so again, Peter, that's completely speculative. So, and you're way more of an expert than me, but I've always been taught, and everything I've seen, is that a 90-degree angle is way better than a 45-degree angle where you could get build up in the corner. You could have potential problems in your corners. And every single board reference design that I've seen, like in terms of small scale, has 90-degree angles over 45 degrees. Like stuff like that in here, that's a potential problem. From what I've been told. From what I've read. Again, don't trust everything on the internet. So I don't use 90-degree angles everywhere, but occasionally I will. My understanding is that this scale, it really doesn't make any difference. But I could be totally wrong. Under the T crossbar. It's not speculative in the slightest. I bought $1 million in Tektronix time domain for somebody to get to study it. Okay. Right. So you think this is really going to be a problem on my board? Like, is it good to do? No. Is that really going to be a problem on the scale of this? Anyway, so what I should be doing is this. Come on, Eagle. Not gonna let me go. There we go. So that's what I should be doing. As I said, I was going to clean it up later. You should have random, almost rectangular angles in your design to piss off OCD people. Yeah, I should. I'm going to move that down. I really shouldn't be doing this live. Oh, it doesn't really matter. And you all reckon I should have matching network. I should have ground underneath. Oops, wrong one. That's power. That'd be bad. So I wonder how close I can get to the antenna. I thought I had to be like 5 mil away from the antenna. I don't know. Right, but it really depends on what it is though, isn't it, Peter? Like doing a 90-degree on the antenna line would be stupid, but on ground, like, you know, yeah, I don't know. I don't know. Well, that's wrong. So a lot of this stuff I also haven't cleaned up, by the way. Like, that shouldn't be like that. Right, let me go back. So, back to blind wires. So I was using blind... So what's cool about a blind wire is, with a normal through-hole wire, see this here? This is going to ground, right? Now, ground's the second layer down. I could trace on my bottom layer through here. So I could do, for instance, I'm just going to whack this in just for fun. I could go right through this. See, this won't let me because the actual wire doesn't go all the way through to the bottom, which means I don't have to move around wires when I'm designing if it's a buried wire, which is really cool. The problem is it dramatically adds cost to production. And as it is, a 4-layer board is much more expensive than a 2-layer board. It should flow. Remember that at the scale, wire becomes both inductors and capacitors. It's touchy business, ground under the feeds and matching, but not under the antenna. Yeah, that's what I've just done here. It's not under the antenna. I thought there has to be a clearance around the antenna. So that's why I went for buried, but then I obviously changed it and I've gone back to completely through hole. So all the wires go top to bottom. Let's not forget there's a development board, not a space station. Very true. I'm, you know, keep hitting the wrong key. Using a different keyboard than normal. I hate having bits of angle. Anyway, I feel like I need to start all this again, this discussion, because I've lost my train of thought so many times. Mute. The good news is cold water doesn't taste as bad as cold coffee. Anyway, so here's a 4-layer board. I have more room now. Oh, I forgot to mention some of the other changes I made. See? Now I got distracted. Okay, more revision 2 changes compared to revision 1. There are 2 IOs on the Pico, or there's more than 2, but there's 2 IOs on the Pico that are inputs only, but they've got ADCs on them, which is cool. So I didn't break them out as on headers. It's 34 and 35, which is called stat. Yeah, that's 34. So what I did was 35, I connected to a voltage divider, and I've got that going to VBAT. So you'll be able to, I know it's a terrible way of approximating, but you'll be able to read IO35 on the board now to detect a rough idea of voltage in the battery. So I thought that was a nice feature to put on the board. And the other thing I've done for MAT, although it's not, I'm still going to have to put a voltage divider in or something, is I've connected 34 to stat. Now stat on the charge is what drives the LED to whether it's charging or not. And so the way stat works is it's high, and we'll talk about what high is in a moment. It's high when the battery's not charging, and it's low when the battery's charging. So what they'll potentially allow you to do is read 34 to see if the battery's being charged or not, for whatever purpose, okay? Between knowing if a battery's being charged or not and knowing what your voltage of the battery is, I thought that was a good use of 2IO that I couldn't break out because they were pointless breaking out because they weren't outputs. So I thought that was a nice touch to put on the board. The problem with the stat is the actual chip is fed by VBus, which is 5 volts. So when the battery's being charged, stat is low, it's 0. Well, pretty close to 0. But when it's not, it's a weird value. It's not 5 volts, but it's not 3.3 volts. I've seen it hovering anywhere between 3.8 and 3.9 volts. So I don't know whether that's a chip, an IC specific thing or not, but I can't just stick stat, like I've got it right now and I can't obviously send this out. I can't just stick stat going into 34 because I can't stick potentially 3.9 volts into the I/O of the Pico. I need to put it through some type of level shifter or voltage divider, but I don't know, what I'm going to use because it's not 5 volts when it's high. So I'm going to have to do some more research to work out what stat's supposed to be when it's high, or work out what range I've got on the Pico on the I/O for it to decide what's high and what's not. Like, is it just the 30-70 rule, 30%, 70% for detecting high and low? I don't know, right? If it is, then I could probably get away with feeding stat directly in, and that'll detect that as high. But my concern is how high can I actually put that in? Maybe I can just do a voltage divider with a very small amount, like, drop it down 10% or 15%, just enough to get it under. But without knowing exactly what voltage stat is supposed to be, that concerns me. That's like fudging it, right? So I've got a voltage divider on the battery, and I have enough room now to stick a voltage divider. Well, the max potentially could be 5 volts, and you can't stick 5 volts into the I/O of the Pico. But my testing doesn't show 5 volts. My testing shows a range of voltages. Now, 3.6 obviously is still high, 3.8 is high, so it will detect it as high, but I don't know if I can feed 3.8 in. Yeah, so I still have to put a voltage divider. Now, I have room to stick another voltage divider in, and I will. I just haven't done it yet. But yeah, I wanted to mention they're two features. I thought it was a good use of 2 I/O that I wasn't broken out, to be able to read whether the battery's charging and to check roughly what the battery voltage is. So that's another feature that Revision 2's got that 1 doesn't have. So I don't know when I'm putting Revision 2 into production. The other thing is I haven't decided yet if I'm going to do 4-layer or 2-layer for Revision 2. Right now, all of the space optimizations I can do on a 4-layer, almost all. Obviously on the 4-layer board, there's a whole bunch of stitching vias that are gone, which is great. So it's a win there in terms of space. But if I go back to my 2-layer Revision 2, I still have a lot of gain here in terms of space, right? Now that I've got smaller annular, if I just put my, I'll actually leave that off. I can pack this in, I can fit 2 more resistors and do another voltage divider here as well. So I'm thinking my Revision 2 boards are going to be 2 layers still, but I might do a run of 4-layer just to try them. Yeah, my concern with 4-layer is, again, as I said, it's quite expensive. I'll do a deal, I think I'll do a deal with JLC PCB. I'll do a sponsored video for my 4-layer ones, and I think that they will give me the boards for nothing this first time. But once I go into production, 4-layer really ups the cost. So, and the other problem with potentially with 4-layer is if there's a problem with the board, if there's a short on the ground of VCC, or if there's a problem, it's going to be, I'm thinking it's going to be harder for me to work out, like to debunk problems potentially on a 4-layer board. I don't know, I've never made one before, but I have a guess that maybe it'll cause me some problems. So I'm thinking I might do both, but what I want to do is make the design the same, get them as close as possible. How much impedance is a 2-layer trading off against a 4-layer? No idea, Paul. I don't know. So one thing Eagle doesn't do is give you impedance values. I know there are other tools out there that can do it. Most of the standalone tools are on a PC, which I've got a PC over there, but I don't have Eagle on there. I don't really want to go down that road. There are websites that you can use to calculate stuff, but you can't just load your PCB design files into it. Once you go into production, everything will go down. It may or may not, Chris, because I might not be going into production of any great value. Like, I'm not going to run out and build 1,000 boards, or get someone else to build 1,000 boards. As much as, it sounds like people are really interested and potentially want a small board, the fact is, there are plenty of other small boards out there. Hat off to you, but can see potential impedance issues. Impedance issues where? You're talking about on the antenna? Sorry, Paul. If this is still all about the antenna stuff you're talking about, I don't know what I'm going to do. Like, I'm going to get varying results from what I've got already. As I said, I don't have the knowledge to solve this in any mathematically calculated way. So it's going to be a suck and see on the antenna. Calculator used for stack up, but it's PC based, right? That's the thing. It's PC. Yeah, I've seen the PCB toolkit. It's all PC based. Might have to do that. So you're seeing an impedance issue on the ground plane on the 2-layer board. Thanks, Paul. I'm winging it. I'm winging it the whole way. I'm learning as I'm going. As I said, I just learned how to do a 4-layer board. That was fun. So I want to change as little as possible as I'm going, right? So if I build the 2-layer board and I build the 4-layer board and I try them both, that gives me the option of seeing the differences between them. Rather than skipping the 2-layer board for the revision 2, I think that'd be a bad idea for me. I know it adds cost right now. The good news is if I get them the same, as in identical layout, at least for now, then I can use the one stencil. That's going to be my plan right now, is to make them identical if I can. But if I can't, I'll just get 2 stencils. No big deal. I'm back. What did I miss? Ha ha ha. Sure if that's not... Yeah, the impedance will increase with the 4 layers, just due to the board thicknesses and stuff, but I'm not sure that it's going to be necessarily a problem on the board. I don't know. We'll see. Like, it's going to be a... That's how I'll find out. I went Elton Designer. Yeah, Bootcamp's pretty good. I could run Bootcamp on here if I wanted to. I don't like living in Windows land, to be honest. I avoid it at all costs. I'm a bit of a snob. And you could just for online courses of tutorials for PCB design. Or Eagle tutorials good enough. I don't know, Des. It's all stacks of videos out there. You just got to comb through them all. So Contextual Electronics do some really good ones. They're not Eagle. They're KiCad or KiCad, however you say it. I don't care. I call it KiCad. He's got some really good tutorials on KiCad, which is obviously open source. That's what I started learning on, but then I moved to Eagle pretty quickly, and I'm pretty happy with Eagle. I started doing some tutorial videos on Eagle a while back, but I never finished them because then they went to version 3. Well, all of this will require rematching antenna, Paul, because my values are just... I don't have... This is just reference values. So this could be completely unmatched anyway, right? So, yeah. I understand all of this. I understand it could be hit and miss. I could make my antenna matching way worse by going 4 layers. I could make it better. this in itself could make it worse than my revision 1. I know all that. But I'm not going to know the answers until I build them and find out. So what else? Does anyone have any other questions? Hey Jimmy. Yes, it is an interesting project. It's very exciting. Like I'm really enjoying this. I've learnt a lot more about PCB design than I thought I would. And optimizing space on design and you know, I enjoy a routing challenge, but I don't enjoy having to reroute and reroute and reroute. That gets a bit monotonous. But it's definitely a fun challenge, trying to pack all this in. And I know I can get this tighter, but you got to remember, I still have to build it, right? Packing in components tighter is great for a pick and place. But when I'm trying to build, like as I mentioned on my build video, let's go back to here for a second. Like an awesome design. Thank you very much, Paul. Catch you later. Thanks for joining. Thanks, Peter. If I just go back to this for a second, right? So the problem with packing parts in is I need to get tweezers in here, right? I need to get, like, if you look at these resistors next to the reset, the twin NPN, like I've moved them to, they're 0603. I've moved them to be 0402 on my new board. Like I need to get in there and put them on with my tweezers. Like my tweezers, I mean, they're pretty small, sharp tweezers. I can't get in there, right? And then if I have to rework them, like I swapped this charge IC out to, like I originally put the MCP and then I put the TP version on there on my first board. I had to get all this stuff off, hot air it off and rework and put them back on. And, you know, I was changing this resistor value out. Like, the more I pack it in, the harder it becomes for me to prototype and design and sorry, not design, and assemble and debunk. You know, like, look at how close that resistor is, that capacitor is. Like, that's ridiculous. I can't get an iron in there now. Like, if I had to put flux and rework the IC, the PICO, I'm screwed. So what I do is I have to take the capacitor off, then rework, and then put the capacitor back on again. Like, it's, at some point, getting it closer for the sake of getting more space on the board. Finer tweezers than this? I don't know. They're pretty fine. Can you get finer ones? Maybe. I don't know. Packing things closer together at some point just makes my life impossible, right? And so I don't want to necessarily do that. I still need to be able to assemble one. And the other thing is, a pick and place is really not going to help me with something like this, because let's be honest, a light placer or any pick and place that I can afford is not going to be able to build this board. Okay, I'm going to get as many failed component placements as I get good placements, right? Cheap pick and places, ad hoc pick and places. See you later, Looney. Thanks for joining. I know you're super tired, so I appreciate it. I don't know if it like I know that the light placer says it can do 0402, but I don't know how reliably it can do it. I've seen plenty of videos of people running pick and places where, you know, a third of their parts don't actually, yeah, haha, Looney, where a third of their pieces, just like components, fall off the head, the place head, and just don't end up on the board. So, you know, unless I'm going to go out and spend $15,000 or $20,000 on a pick and place, I don't know that there's a pick and place out there that's going to be able to do this for me reliably. There's no way a light placer can put that cap there next to that IC. Can I sharpen the tweezers with a diamond file? I don't know. Maybe. It's not the point. It's this. Yeah, I don't know. Maybe I can get thinner tweezers, but the point is, it still becomes a hassle for me, right? Like, there's no point designing something I can't build myself and prototype myself. And I would assume that the more intricate the build, potentially the harder or the more expensive my PCBA cost would be if I was going to outsource them. That, and if you get a board with one part that didn't solder properly, you want to be able to fix that rather than bin the entire board. That's right. I want to be able to rework the board. I need to make sure that I've got enough clearance to be able to get in there and rework. So going smaller parts and getting them closer together. I mean, I can stick some 0201 on there if I have to. Even with my magnifying glass, I'm pretty sure I could do it. With my microscope, it's still in China, unfortunately. It's been shipped, but it's, yeah. Excuse me. I might be able to put some, 0201s on some of the small resistors. Keep them out of the way. The assembly line guys at the factory I used to be in would scream at the layout, and they'd be like, let's just do 0201s all day long. That's right, the placement head needs room. Like, there's no way a placement head can get... Because if you look at the height difference, I don't know if you can see it, between the caps and the Pico, there's no way a placement head can get in there and place that. Well, maybe on a $500,000 pick and place machine, but not on a $3,000 one or a $5,000 one. It's just never going to happen. So, yeah. That's my challenge. Make it smaller, pack it all in, but still be able to build it, and it still needs to be able to be manufactured. Now, like you saw, I mean, my build with my magnifying glass on this was pretty good. Like, it was pretty easy, comparatively, than what I thought it was going to be. I had a lot more fear building my first one than I did with my second one, because I'd already done it. Placing the Pico is kind of difficult, as I said, because of the pads being underneath. It's really hard to see the alignment. I'm actually thinking that I might go into the footprint of the Pico and actually extend the pads out a fraction, about another millimeter, just so I can visually see them when I'm placing the IC. Because it's very hard to get it on. Like, you're totally guessing. Like, I can't even see from the side. Like, you could almost... Can't see it. Hang on. I know it doesn't help the camera. You can just see the glittering tinny bits, right? Like, it's just, you can't see, especially with the components in the way. You just can't see where the pads are. So that's something I think I want to do as well, is just increase the footprint size a little bit. Are you being facetious there, Peter? It's not like boards ever need rework before leaving the factory. Yeah. You never know how much rework they have. Now, something else I need to do, which is going to be important if I go into any form of production, and I should have done for this anyway, but I wasn't sure if I was keeping the same form factor, and I have changed the header pins, is I need to build some type of testing rig. No, I'm not planning on doing BGA, Stephen. See you, Des. Thanks, mate. Yeah, John, I agree. Yeah, extending the pads, just for my own sanity, I think it would be better. Yep. And not only will it be easier to check for shorts, but it'll be easier just to, whack some flux around the side and run the iron around it just to, to do that anyway. I probably should be doing that on my QFNs anyway, just to ensure that it's nice and clean underneath. I need to build a testing rig, so I was thinking of... And this will have to probably be a custom board. I don't know. Probably a custom board. I'm not going to do it on Proto for sure. But if it was something that would sit in, like, just on some pogo pins or something that would plug in, and the idea is I'd have a screen. It's going to zoom out a fraction. I'd have like just an OLED screen or something and a button, and I hit a button and it'll, like, I'll have some code on there and it'll actually run through a whole bunch of code and it'll check every single I/O. It'll read to and write to every single I/O, and it'll do a whole bunch of stuff and check the battery and everything, and then give me like a pass-fail check or something on the display to let me know. I can avoid BGA for the moment. One day maybe I can't, one day, but right now I can avoid BGA. I know a lot of stuff's going BGA, but I don't mind BGA where the balls are just on the outside. I've seen a few ICs like that, but I wouldn't want to have to reball BGA. How about ordering the bare dies from the chip manufacturer and doing the wire bonding yourself straight to the board? Azzy, slap yourself across the face. Do it right now. Slap yourself. Packages with leads. You mean QFP? QFP obviously is nice, but it takes a lot of space. Like, I like here, if you look, let's go back closer again. The CP2104, the footprint on that's great. Like, you can see the pads. It's really easy to see if there's a short. It's really easy to rework and to clean up. This one, not so much. It's all like magic underneath. Yeah. So, I think a very important step is going to be a testing thing. Now, the other thing I want to do with the TinyPICOs is I don't have anything done or finished yet, but I'll show you here now. I started working on shields. And interestingly enough, so this is the old design. This is revision 1 design. But I just thought I'd show you anyway. But my original plan was, don't worry about these diodes. My original plan was to do a bare shield and then make a whole bunch of different shields. I did it, don't worry. That pause though after you read my post made me think you're considering it. No, I was trying to understand what you wrote. See you, Stephen. Thanks for joining. Really appreciate it. My last Thunderbolt board had a few chip scale packages with only the silicon and solder balls. It's closer than you think. Yeah. I'm just being ignorant. Not ignorant, sorry. Was it ignorance? Ignorance is bliss. Something like that. Whatever the saying is. Yeah, I'm just pretending it's not happening. So, yeah, I want to do shields, right? I want to do like an OLED shield and some other things as well for it. Just, why not? And so, I just started off with a blank one. Oops. And then so the first shield I was going to make was my Lipo Shield. And this is before I put Lipo on the board. So, I did a Lipo Shield for revision 1. Which is this here. And then Matt turned around to me and went, oh, come on, there's so few parts. You could fit that on the board. So I did, and that's why I put it on the board, and I'm glad I did. I'm glad the board's got built-in LiPo. But I'm definitely going to do at least a prototyping shield, like an empty shield. It's got just pads for prototyping. But I'm also going to do one of these. Hang on. What time is it? Wow, I've been going for 2 hours already. Wow. So, for those of you that saw my mail video, this color IPS screen. So look at this. Look at that. How amazing. I mean, obviously that's just sitting on the board. So that's another compelling reason not to make the board smaller. Because I don't think I could get, maybe, might be a problem soldering headers if I make it smaller. So right now, that's, I mean, in terms of the Pico size, that is perfect. That's a color IPS screen. I've also ordered a bunch of just white OLEDs of various sizes, you know, the little ones you can get. But like this, you know, with, you know, not on a module, obviously. They're coming from China as well. So a couple of various sizes. So this one's a perfect fit right now. I've got a thinner 0.9 1 inch, whatever, coming. One of these ones. OLED. Where's my OLED screens? Just one moment, folks. I'm looking for my OLEDs. Hey, Charlie. I've got one of these coming. So as you can see, it's narrower. Oop. Try to get it straight. It's a little bit narrower. and they're just you can get them in blue or white. So I've got one of these coming, and that would fit nicely on a narrower board. If I can just get it on. So I could probably use one of those, but it'd be nice to have a colour screen. I haven't found a colour screen smaller than this yet. I mean, that's a colour OLED. Pretty big, obviously. I think this is a colour OLED. This one, is it? Yeah, no, maybe not. Anyway, so I want to do a, cheaper to get them in module and desolder them. Yes, it is actually cheaper to get some of them in modules. Oh no, this was $4 or something, and this was $3.50. Just from Ali, just a one-off. I have not found these. So I got my other displays from, I think they're called buydisplay.com. They manufacture a whole bunch of different displays. And you can buy them in bulk from there. It's not like Ali. They don't sell an Ali that I know of. And they come like this, and you can get the sockets as well. So I got sockets coming for the other screens, but I couldn't find a socket for this. So this is a weird number. This is I can't remember how was it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This has got 13 pins on it. I've not found a socket for 13 pins. So I've ordered a socket for 15 pins that's got this pitch, and I'm hoping I might be able to use that as a socket. If you actually look at this board, they don't even use a socket. They just hand soldered that on, and that looks ugly. So I could always do that if I have to. But yeah, I want to make a some type of screen, whether it's OLED or IPS or whatever, would be a nice shield. And then I thought potentially some other shields, like a battery backed RTC. I know that the SP32's got a RTC in there, but it's not battery backed. I mean, that's fine, but when your battery runs out, you're in trouble. But of course, you can't stick a 2032 battery on this, so I'll have to go for a little tiny battery. BuyDisplay does sell on eBay. Yeah, sorry, I know. So BuyDisplay sells on other places, one-off and stuff. But if you want to buy bulk, you go directly to them. That's what I was trying to say. Like if they've got this on eBay and I buy 10 of them, I'm paying 10 times the one-off price. But if I go to them directly, I can get a 10 off price. That makes sense. I think my voice is going. And I also thought, so a lot of the pins have got cap touch on them, so I thought maybe a capacitive touch shield might be nice as well. I don't know. And the other thing I want to do is, make the shield design open source and let people make their own shields for it if they want to. No, it's not, soldering them is not ugly. The job they've done is ugly. I'm not sure you can really see. It's just let me see if I can zoom in a bit. They've just done an ugly job soldering, is all I'm saying. It just looks a bit ratty. That's all I meant. Okay, so I think that's everything I wanted to cover today. So I've been procrastinating a little bit about getting revision 2 finished because I keep adding more improvements and changes. But I think I want to wrap it up, maybe even today. At least the 2-layer version. I might get the 4-layer version printed later. I don't know. So I'm just loading up the 2-layer again. I saved it with the PS RAM. Yeah, it's hard to explain. Maybe you can't see it on the camera. Like some of the pads look... Rusty is not the right word. I don't know what to call it. Like, it's just... Yeah, I don't know what the word is. Maybe like some flux and just running my iron along it will fix it. But just some of these pads, they just look... I don't know. They look really ratty is what I meant. They're discoloured and they're just... Anyway, whatever. Whatever, I'll go back to here. So, I just need to stick a voltage divider on the stat. And I might close the gap up, like I might close them up a little bit more to make a bit more space to the top. The other thing that I was thinking of putting on and it wouldn't fit early on. Sorry, mute. Sorry about that. Yeah, it could be flux. It doesn't... Yeah, I don't know. I don't know what it is. It's only on the pads. Anyway. Another thing that I wanted to do was to... Because right now I've got, obviously, pin 13 is just a flashing blue LED. I thought of sticking a SK6812 or something like a 3535 on here. I thought of putting a dot star on, maybe, like a 2020 dot star. They're a bit... Like, I need more than one I/O for that. I need a clock as well. So I'd rather do a single one. The problem with doing that is, I'll show you, they are massive. Oh, what are they? No, that's not what I want. Here's my 2812B. That's a 50/50. Here's one. Okay, I'll just use that. So this is a 3535. Oh, go away. It's pretty big, right? So, again, if I'm going to put PS RAM on the top of the board, there's no room for this. But I could potentially... A dot star matrix shield would be cool. Well, you'll be able to make yourself one, Azzy. If I squeeze all this stuff together, now that I've got some extra space, I could actually get... So I'd have to decide that I'm not going to ever make the board thinner, right, narrower. So, because once I make the commitment of adding stuff that can't allow me to make it narrow anymore, then it's done. Or if I make it narrower, then there's no ability to do any of this stuff. But what I could still do this board, I could easily fit a 3535 now. Right, even there. Like, as long as it's far enough away from the antenna. So I could get rid of the little blue LED and do this instead. And I'm thinking maybe I might do that. It might be nice. But I don't know. I mean, a little flashing blue LED is kind of pointless, right? I guess they're just to do a blink test. It's just there to do a hello world. I don't, like, I know there are a lot of boards that have, you know, like a dot star or like an RGB LED on the board now. But I don't know what that's useful for. I mean, to me, the only thing it could potentially be useful for would be to have it display a particular colour for a status on something. Now, what Adafruit do with theirs when they have like a little dot star or something on there is they actually, in the firmware of their chips, they have the dot star show particular states based on the board state. But, excuse me. But I'm not planning on changing firmware on the Pico, so I'm not going to be able to do that at a hardware level. So it could be there for people to play with to do, but I don't know what you'd use it for. You know, you'd have to run specific code to be able to control them, unlike an LED that you can just turn on and off. So yeah, I don't know. That was another idea I had. And I'm actually out of I/O that I can break out on the Pico right now, so another idea I had was to actually extend the headers here and put 2 more on there and break out 2 more I/O, but there's nothing left. There's I/O 2, but that's a latching. 5's also latching, but 5's also clock on the SPI. So I'm actually out of I/O. There's really nothing else to break out. Very useful for bootloaders. They are useful for bootloaders, but that's not a thing on the Pico, like on the ESP32s. Like, when are you swapping bootloaders? The bootloaders have to be custom to be able to do something specific with a dot star or something, and that's what Adafruit have done. Like, they've actually written stuff in their firmware to do that, but I think that's way out of my scope. Lipo charge state status. Right, but that's something that you'd program, but I can't just have that running. I can't have 2 lots of code running on there. Like, when you put code on your board, it stomps the other code, right? I'd have to either build that into the hardware level, into the firmware ASI, which I'm not going to do, not going to happen, or you could potentially do that, but then if you don't do that in your code, then the LED sits there doing nothing, right? And even if it was at the firmware level, it would have to understand that, okay, it's running off battery right now, don't do anything on the NeoPixel. It's great for going between. I know they make 2020 of the WS. I've looked online. I found a place that, they're not overly cheap unless you buy in bulk. I could definitely do a 2020. I thought of buying a whole bunch of them. But I still struggle with understanding what it's going to be useful for. Switching bootloaders is great to go, John, between MicroPython and Arduino, but again, that LED is not going to, the NeoPixel is not going to do anything unless there's functionality inside the bootloader to control it. So, I'm not writing the MicroPython bootloader. Maybe Matt can get that organized, I don't know. Your antenna inductor value is shown as 10 times the values I see in other schematics. The 18 nanohenry. I don't think so. I've seen one 16, I've seen one 18. Or is it 1.8? It could just be a typo on my behalf. Is it 1.6, 1.8? I don't know, I'll have to look. I'm pretty sure I ordered the right value. I don't even have all my stuff I work on my Mac here. Hang on a second. One moment. Hello, wake up. I'm just looking now. Bear with me a second. Yeah, it should be 1.8. Yep, just a typo. Yep, it's just a typo. I just checked. I've actually ordered the right parts. I've ordered a 1.6 and 1.8. So I will fix that now. Thank you very much. Just a typo. Unexpected bootloader programming. No, not going to happen. I don't think so. I'm designing hardware so I don't have to do software, remember? I think Matt's in bed, lol. No, Matt's at work. If we're talking about Matt Trentini, he's gone to work. He's in Melbourne. He's with me. So yeah, that's my run up for revision 2. Not sure what else to say. It's I'm gonna look at those MCP7. Let's look at this MPC 1700. Do it over here so everyone can see. What was R? Who's saying R? Oh, right. I am MCP 1700. I think if people want an LED, they should provide the one of their choosing and connect it to an I/O. Yeah, that's what I like. Again, having an onboard RGB LED, I think, is just. Can you change Australian time zone? 2 p.m. is a bit early. Have to watch it work. Sorry, Michael. So how much are these? Oh, okay. Oh wow, it's an interesting package. 3.3 volt. Oh, it's only 250 milliamps. SOT 23.3. Interesting. 54 cents. Let's look at the data sheet. Low quiescent current LDO. Oh, what just happened? I don't care if it's not secure. Let's try that again. Where can I source the stackable Arduino headers, as in bulk rather than from SparkFun? LCSC, I mean obviously AliExpress, but LCSC have them, all the different sizes, stackable headers. So 1.6 microamp quiescent current, input voltage range, output voltage range. Ooh, it can go up to 5 volts. Interesting. Can everyone read this? 50 milliamp, low dropout. 178 milliamp drop, that's not bad. Output voltage options, 1.2. Stable with... Wow. This looks pretty good. I might... Unfortunately, it's both wrong footprints. Hit refresh, it's a bug in Chrome. Yeah, I only use Chrome on this machine. For some reason, Safari doesn't work properly on the Hackintosh. Whoops, did I say that out loud? So if this was just a swap in, I'd get some, but this is a board change. That sucks. But wow, this is quite low. Let's lcsc.com. Let's see if I've got them at how much they are. Nice to meet you. MCP 1700. LCSC aren't overly cheap on microchip parts because they're American. So which one is the one I was just looking at? I wonder if there are different package types. I mean, no, there's only those ones. So, I hate when they stick all these codes on it. So it's a T3302E TTTRND. Really? I hate when they do that. I know they've got different codes whether it's a reel or a tray or a blah blah blah, but come on. So which one do we want? Okay, let's sort by price. Hey Carl, how you doing? Welcome. So, positive fixed number of regulators, 1. Can I choose package type? Do I want SOT 23? Do they not have SOT 23.3? Oh, there it is. Okay, apply. Oh no, I've got the part, that's fine. Price, sort. Whoa. So, the cheapest they've got, wow, 28 cents. Well, obviously, I'll be looking at the 100 level. 19 cents. Buy 100 of these. So right now, the LDO that I've got is 600 milliamps output. But I don't need that much, do I? 250. Not clones and else. Most likely I've got cheap reels. Yeah, it's not clones here. That's why the often the parts, like US based parts, are more expensive. Like the all the SAMD stuff is like really expensive here. Like I can buy DigiKey for 30% cheaper. I can buy Arrow 50% cheaper than I can buy from LCSC on American stuff. Yeah, there's no clones in LCSC, which is good. It's reliable to buy. These are pretty good. I'm going to buy some of these, so maybe I'll move over to these. This will drop my... So the quiescent current goes down from 55 to 1.6. That's pretty spectacular. So for the fast scrolling, so typical application, just a 1 microfarad cap, don't need a 10, that's what they reckon, and a 1 in. Well, that can save some space, get rid of a 0603 10 microfarad cap. So how do you tell it to go 3.5 volts out? Isn't there a resistor somewhere? Low quiescent current and low drive voltage, ideal for many battery applications. So how do I tell it to go 3.3 out? As will change when Trump's new tariff regime is implemented. Well, isn't it already implemented? Oh, they're fixed, are they? Oh, I saw fixed, didn't I? Right, okay. So that's what the 330 is. Okay, perfect then. Cool. Sorry, thank you, Peter. Okay, yeah, it wasn't. I skimmed right past that. Yeah, this is fixed 3.3. Interesting. Okay, so maybe I will move to this. Okay, another change. Except I've got like hundreds of AP2112s. Hundreds and hundreds. But it's probably a good move, although, I mean, 50 microamps isn't a huge amount. But everything counts, I guess, when you're running off battery. Okay. I will make a note of that. Done. Okay, folks, I've been going for 2.5 hours. I'm surprised I lasted this long. I thought I was going to bail early. Thank you all for watching. I don't even know how many people are left. Probably not many. We had 67 on peak. Awesome. And I finally crossed the 1,500 subscriber count threshold. Woohoo! Yay. Onwards and upwards. But I think I'm going to call it now, everyone. Unless anyone's got any more questions or comments or suggestions. Thanks, Chris. You should be asleep too. Go to sleep. Thanks, everyone. I appreciate you all your help and advice and comments and questions and joining me on this journey. I know I seem to be all consumed TinyPICO right now, and I've got a whole lot of other projects that are sitting there doing nothing. But, you know, that's just the way it is right now. I'm a bit fixated on this. I want to get to the next section of this. Thanks, Azzy. Good night, all. I really appreciate it. Thanks again, Peter, for your help, your awesome help. Everyone's help, thank you. Yep, okay, I'm going. Sorry. Bye, have a good day.